So first off, what do you guys remember about sine, cosine, and tangent? Okay, so sine is opposite over hypotenuse. What's cosine? Adjacent over hypotenuse, and tangent is opposite over adjacent. What's an acronym that you can remember? Yeah, SOHCAHTOA. SOHCAHTOA, so this tells us sine is the opposite over hypotenuse. So if we want to write the ratio out for sine, we take the opposite side over the hypotenuse. Cosine tells us it's adjacent over hypotenuse. So we take the adjacent side over the hypotenuse. And then tangent is opposite over adjacent. Most of you guys remember that? Okay. So now what we're going to do, actually just for starters, is I just want us to write the exact trig ratios so that we all know where the opposite, adjacent, and hypotenuse sides are. Okay. So this is the first example. On that sheet, we want to find the trig ratios for each of the following. So the first row is dealing with your angle A. Okay. So this first row, we have sine, cosine, and tangent of A. So what angle are we going to focus on the diagram? A. So if you are not good at just looking at the triangle and figuring out which side is which, I'm going to strongly suggest that you label the sides. So A, what side would be opposite from A? 12. So you can label that side with an O standing for opposite. Which side has to be the hypotenuse? 13. How do we know 13 has to be the hypotenuse? It's the longest, and if we don't actually have a measurement there, how can we tell? It's always across from the 90. It's always across from our 90 degree, which means 5 must be which side? The adjacent. It's right next to our A. Okay, so if you have this set up, and if you have the three sides labeled, writing out your three ratios would be pretty easy. So what is sine of A going to end up being then? 12 over 13 because it's opposite over hypotenuse. What would cosine of angle A end up being?
5 over 13.
Yep, 5/13 because it's adjacent over hypotenuse. And what would tangent end up being? 12/5. You guys remember this much from geometry? Yeah. Okay. So now B, angle B. So if we want to find angle B, what angle do we have to look at? Yeah, I now have to look at B, which means are my opposite and adjacent sides labeled correctly? No. How about the hypotenuse, though? Is that one okay? Yeah, the hypotenuse won't change. So now if I'm looking at angle B, which side is the opposite? Now 5 is opposite and 12 is adjacent. And like I said, if you're really good at this, you don't need to label it. But if you're someone who struggles at not knowing which side is which, label it. It will help you. Okay? So now what would sine of B be? Yeah, 5/13. Cosine of B would be 12/13. And tangent of B would be 5/12. Do you notice any relationships here?
Well, for the sine and cosine, the numbers the same on the bottom. They're switched, actually.
Yeah, sine of A is equal to what? Cosine of B. Okay, so sine of A and cosine of B are the same. That'll be the case every time you have a right triangle. How about the sine of B and cosine of A? They are also the same. How about the tangents of the different angles? They're just reciprocals of one another. That's a relationship that'll happen for every right triangle. So it doesn't matter which angle you have, you could find out all of them. So we're going to do another one that's got some square roots in, so we're going to do this one. We want to find the exact trig ratios. First off, does anyone notice what type of triangle this is? I think this is the fourth one. Yeah, this is a 30, 60, 90. How do we know this is a 30, 60, 90? Yeah, this side is like your x. Your hypotenuse is like your 2x. And your longer leg is like your x squared to 3. So 1, 2, and square root of 3 would be a 30, 60, 90. So we know that by the sides, but let's just write the ratios out. So for A, the top row is once again A. What will my three sides be labeled as? Which one will be which? Okay, so the opposite is square root of 3. Hypotenuse is 2, and that leaves 1 with what? Adjacent. Okay, so sine of A. What would sine of A be? Yeah, square root of 3 over 2. What would cosine of A be? Yeah, a half. And what would tangent of A be? Yeah, just square root of 3. Why is it just square root of 3? Why don't I have to write the over 1? Yeah, it doesn't really matter. It just simplifies down. Okay, so now if you know the pattern, you could certainly just flip it around to the correct way, but let's actually look at terms of B. So now if we look at it in terms of B, which one's the opposite and adjacent? Opposite is 1. Adjacent is now square root of 3. So sine of B, what would this be? Yep, 1/2. And notice it is the same thing as our cosine of A. Cosine of B, what is that? Yep, square root of 3 over 2, and it is the same thing as our sine of A. Tangent of B. Okay, 1 over square root of 3. Now, is that simplified? No, because we have a square root in the denominator. So what can we do to simplify this? By what? By 2. Not by 2, yeah, by the square root of 3. So if we multiply this by the square root of 3, we have the square root of 3 over 3. And these are reciprocals of each other. I mean, we can see square root of 3 and 1 over square root of 3. They're reciprocals. We just have the simplified version. That okay? All right. I just want to make sure everybody knows how to use their calculators here. Just want to make sure. So we're not really going to do all these. We're just going to do enough so that I know everybody actually knows how to use their calculators correctly. Because if you don't, you will not be able to do most of these problems. So we want to go to the nearest 10,000th. So 10,000th is how many decimal places?
8. I don't know.
Yeah, it's 4. 10th, 100th, 1000th, 10,000th. So 4. So sine of 56, go ahead and put that in and tell me what you get to the nearest 4 decimal places. Everybody able to get that? If you are not, there's a couple of problem shooting things. Your calculator has to be in degrees, so you should either see DEG on the screen or a D on your screen. If you don't, you need to change it to degrees, and if you're not sure how to do that, let me know and I can help you. But we will be working with radians a little later in this chapter, so you need to be able to be aware that you're in the right units. You have a fixed set on your calculator, you need to take it off of fixed mode. Okay, and I can help you do that. All right. So let's just do the cosine of 72. What do you get to the 10,000th? Yeah, everyone able to get that? We'll talk about that next. And then how about the tangent of 82? 5 what? 5 forks. We got a round. All right, everyone able to get those 3? Okay, good. So we're all remembering how to use our calculators, which is what I was hoping for. Okay, so now, also you have those little -1 signs, right? So what do those -1 signs mean? Does anyone remember? Yeah, it's the inverse, but when do we actually use the inverse? Okay, when it has a variable where? when we're trying to find what part of the triangle would we use it? An angle, yep. So when we're trying to find an angle, so like for all of these, notice we don't know the angle, and we want to find the angle measure. So when we're trying to use the angle, we have to use the inverse of sine, cosine, and tangent, which is that -1 means the inverse of it. So sine of -1, cosine of -1, or tangent of -1. Doesn't matter which function you have, right? So if you're given the sine of something, you have to use the inverse sine to get the angle. Cosine of something, you have to use the inverse cosine to get it. So once again, we'll just try a couple of these to make sure we can all do this correctly. So this first one up here, so this should be the next box down. Sine of x is equal to 0.7880. What would be the angle measure to the nearest degree? To get that -1, probably most of you have to use your second button.
Wow.
51, yeah, 51 degrees. Everyone getting 51 degrees here? No, it just says to the nearest degree. Oh, 52. Oh, man. I was just listening. And then I typed it in, and I saw it was definitely 52. Cosine. I better type this one in, too. 59 degrees. And then tangent.
55.
Yeah, 55 degrees. Is everyone able to get those? Yes? So everyone's able to use their calculators correctly. Okay, so now let's actually apply this. So if you remember 30, 60, 90 triangles, you can certainly do 25 and 26 using that. But I want to have us do sine, cosine, or tangent so that everyone remembers how this works. Okay? So the general way there's a lot of different ways to think about it, but this is the general way how I show my geometry students to do it. So this is probably the way how you learned it last year. Take a look at the triangle you have here and identify which angle you know. So which angle do you know? 30. So I usually had my geometry students circle that. Now, you guys are in Algebra 2. Most of you probably really don't need to do that step. Okay? So you have 30 degrees. Now look at what sides you're given and identify them as opposite, adjacent, or hypotenuse. So what is x in relation to 30? Opposite. And what is 10 in relation to 30? Adjacent. So now we have opposite and adjacent here, so we want to think, is that sine, cosine, or tangent that relates opposite and adjacent? It is tangent. So now we're going to write our equation out. So tangent of our angle measure, which is 30 degrees, is equal to opposite side, which is x, over adjacent side, which is 10. Then we have to solve this. So how can we solve this now for x? Yep, multiply by 10. So we'll have to take 10 times the tangent of 30. And then we want to, we're going to round the side to the nearest tenth. And we'll do that for pretty much this whole time. So what do we get for our x to the nearest tenth? Yep, 5.8. Everyone able to get 5.8? Or is this refreshing your memory as to how this all works? Yes? Okay. All right, number 26 then. So what's the angle measure that we know? Okay, so we know 60. And so there's our 60 degrees. So now in relationship to that 60 degrees, what sides do we have?
Hypotenuse and adjacent.
Okay, so which one's the hypotenuse? X is the hypotenuse and 3 is the adjacent. Okay, so now I need to set my equation up. So I have hypotenuse and I have adjacent. So which are the three trig functions? Cosine. Okay, so we'll say, all right, cosine of, what's the angle measure? Of 60 is equal to 3 over x. And then how would we solve this for x? Okay, so we'd start by multiplying by x. So now these x's cancel. So now I have x times the cosine of 60 is equal to 3. So divide by the cosine of 60. So I have to take 3 divided by the cosine of 60.
Why couldn't you
Yeah.
Why couldn't you divide instead just divide that by 3?
Why couldn't we do what?
Divide 3x by 3. So
Why couldn't I divide this by 3?
yeah, like
Then our x would be in the denominator still. The x has to be in the numerator in order to solve for it. This would be a case where you saw this is a 30, 60, 90, so if you remember the relationship, it's a very quick thing to say 6. If you don't remember the relationship, though, setting up sine, cosine, and tangent will allow you to get there. And then I'm actually going to change example 27 a little bit. We are not going to know the angle. And I'm going to make, let's see, side x be 21. And we want to find the angle measure. Okay, so we're still going to think about this the same exact way. So we still want to think about the angle we know, or in this case, it's the angle we want to find, which would be this x degrees. And then with respect to that angle, what two sides do we have? Okay, so opposite and hypotenuse. So which one's the opposite? And the hypotenuse is 21. So which of the three trig functions relates opposite and hypotenuse? Sine. So this time we would take sine of our angle. But do we know our angle? No, so we're going to say sine of x, because we don't know it, is equal to, and then what would we write the ratio out as? Yep. Okay, so now we're looking for an angle measure. So which function do we have to use when we look for an angle measure?
Inverse sine.
The inverse sine, right. So we will have to take sine to the -1, or the inverse sine of our ratio of 17.8 over 21. And we should get an angle measure, and we'll go to the nearest degree.
It didn't work.
Oh, okay. You can't use your fraction button because you have a decimal, so you have to use your divide by button. And what was your question, Joshua? I just didn't hear you. This is the sine of an angle measure. So the only way to get the angle measure is to take the inverse sine of it to get it out. Kind of like how we couldn't just divide by a log either. We had to actually apply a function to it to get it out. So like when we had the natural log, we couldn't just divide by natural log. We had to take e. We had to take another function to it. Same idea here. You have to take a function to it to actually get that variable out. And so what did we get? 58. Yeah, 58 degrees.
was 26, is that 6 or?
Yeah, 26 is 6. All right, is this a refresher for you guys? You remember this? Okay. There's one other thing that you also did with this in geometry that I didn't put a problem up here on, but I put some on the worksheet. So I just want to talk about it briefly. And that is like the word problem types of things. So we're going to make one up. A 25-foot ladder is resting along a building. I'm writing too fast for the marker to keep up. Is resting along a building. It is 6 feet away from the building. How high, or what's the angle what is the angle of elevation for the ladder? Do you remember doing problems like these? Yes? So what was the key to doing these? Okay, so this one's very clear because it says elevation, but you have to decide how you want to draw your triangle first. And for many of you, when you draw out descriptive pictures, it really helps you with that. So we all know what a ladder looks like resting alongside of a building. So there's my ladder. There's my building. You get to see my awesome artistic ability here. Okay? And you're going to make a right triangle out of it. So it says the ladder is a 25-foot ladder. So where would we put that? Yeah, the hypotenuse, because that's how long the ladder is. So we would label that as 25 feet. And it says it's 6 feet away from the building. So where would that be? Yep, on the bottom. And we want to know the angle of elevation. So where would the angle of elevation happen? Is it going to be this angle or that angle? Yeah, the one at the bottom. This is our angle of elevation because you start off looking at the horizontal and you are going up. That's your elevation. Okay, so now how are we going to solve this? Yep, so we want to identify the angle. So here's our angle. So we have the hypotenuse and the adjacent. So which one is that? Cosine. So cosine of our angle is equal to what? 6 over 25. So how will we actually get our angle measure out of there? Okay, so cosine of the negative 1 of 6 over 25. Yeah, let's go to the nearest degree. Yeah, so 76 degrees would be the angle of elevation. All right, so that's just taking the knowledge of sine, cosine, and tangent and then applying it to actual problems. All right, is this okay? Yeah. All right.